Alhamdulillahi Rabbil Alameen. As-salatu was-salamu ala Rasulullah sallallahu alayhi wa sallam. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to the class. I hope all of you are well and safe, inshallah ta'ala. Previously we discussed different scenarios to understand the realm of big data. I think by now most of you will hopefully be able to distinguish whether you're working with big data or not. Towards the end of the previous lecture, I also introduced Spark and its architecture. Most importantly, the role of Spark in the big data ecosystem. As we point to the ecosystem, it should be clear that Spark, like other components of this ecosystem, is used for large data sets that require distributed computing for processing and for output. In today's class, we will use Spark, and hands-on approach, inshallah, for data wrangling. What is data wrangling, if you are wondering? Simply put, is the process of cleaning, structuring, and enriching raw data into a desired format for better decision making in less time. That is, to be more efficiently. In context of data wrangling, when we will talk about data wrangling, we will use two most popular Spark APIs. Number one, Spark Data Frames, and number two, Spark SQL. We will start small, learn Spark programming on smaller data sets, then you can experiment on big data sets in similar ways. First, we need to be clear about the concepts of Spark and about the programming itself. Therefore, we will need to discuss the functional programming concept of Spark, which is probably different from other programming languages that you have learned so far. We will work with maps, lambda functions, etc. while we program in Spark, inshallah. So, functional programming. Spark is written in a functional programming language called Scala. In functional programs, we solve the problems in a slightly different manner compared to common languages like Java, Python, etc. Now, does this mean we can't use it with Java or Python or R? In fact, as a part of this course, we will be using the Python programming interface, or what we commonly call a PySpark. However, the approach to programming will be different. So, we need to understand the difference between functional programming compared to procedural programming. Now, procedural programming is what we are usually used to, right? So we need to understand the difference between functional programming and procedural programming. In the MapReduce example that I used in the last lecture, remember when I wanted to count the number of deaths for different countries, A, B, C, D, what did I do? I counted deaths for country A from one HDFS partition, and then I counted separately the number of deaths for the same country from a second partition, and so on. Right? Similarly for country B, you look into one partition, then the other partition, and the other partition, and so on. Once you have those tuples, they are shuffled, then they are grouped together, right? Country A, all the records, all the tuples for country A are brought together, country B are brought together, and so on. And then finally, once you have them together, then we add them up together to achieve the final sum for a particular country. Would you do the same in procedural programming, in the programming that you have done, for example, in C++ or in Java? Would you actually do that? Did you think about it while you were watching the previous lecture? On the contrary, what we would do is we would write a for loop and use a counter variable. Every time you encounter a record, you add one. When we would encounter in a set of data country A, in that loop we would add country is country plus 1, or counter is counter plus 1, something like that. So we would read through the data records, and every time we would encounter a record, we would just increase the counter, and we would know the number, right? So we would do the same for other countries, perhaps using the same loop, or you could use different loops depending on how you write the program.
So in a nutshell, we will run the loop until we finish counting all the records for a particular country, let's say country A in a table. Right? Now this is procedural programming. You write a loop, you run the loop, you keep on increasing the counter by 1 every single time a record is encountered. But we didn't do this in the MapReduce problem example. What we did was we mapped, we shuffled, and then in the end we counted. Right? So this is functional programming. Now the question is, why does Spark use functional programming in the first place? Because functional programming compared to procedural programming helps to minimize errors when it comes to distributed systems, because in terms of big data we are talking about distributed systems. So procedural programming is more effective for the reduction of, for the minimization of errors. We'll go through an example to demonstrate an error that can be created because of procedural programming. Okay, let's head out to our Colab notebook. Now, I assume that you're already aware of the Google Colaboratory. Basically, it's a free environment that Google provides us that we can run our code on. Google literally provides you the RAM, the disk space, etc., so that the running the code doesn't take toll on your machine, or if you don't have a machine which is capable of running code, it doesn't have enough RAM or disk space, you can just use the Google Colaboratory. And we're going to try to use Google Colab for the same reason, so that we don't have to burden our machines, so that if some of you who don't have enough RAM, etc., can just use Google's free service. So you can either just Google up Google Colaboratory and it will take you there, or you can just type in the URL colab.research.google.com and it will bring you to this screen. Once you are at this screen, you just simply have to go to the file menu and click new notebook. Right, and there you have the notebook. It's loading, we're waiting for it. Okay, and so there you have the notebook. You can write your code in here. Of course, don't forget to connect so that it connects to the server, to the backend, and then it gives you the necessary RAM and the disk space. In here you have you can have two types of cells, the code and the text. It behaves exactly like a Jupyter notebook. Yeah, so you have the code, you have the text. If you want to write the code, insert the code cell. If you want to write the text, insert the text cell, and you can start. Now, okay, coming back to the example that I was talking about to demonstrate the error that can happen because of procedural programming. So I'm going to count the number of countries I'm going to store a few countries in a variable, and then I'm going to count the number of countries. Let me just get started with the code. So this is how I'm going to store. I'm going to call it log of countries and just put some name of a few countries in here. Malaysia, Japan, Afghanistan again. Later I want to count how many counts of a particular country. So say Jordan, let's put Malaysia again, let's put Afghanistan again, and I'm going to end with Malta. Okay, so now I have written the code. In order to execute this code, there is this button right here, the play button, the run cell. So you can just click and run an individual cell. So we'll just run them as we go along. So I'm going to click on this one. So done. There's no output because I'm just trying to store the list into that variable. That's all. I'm going to insert another code cell by clicking the code button, and I'm going to declare another variable called country underscore count, initialize it with 0. Okay, and just run it. Okay, and then I'm going to insert another code cell. Now I'm going to write the Python function to count. So I'm just going to call it count underscore countries. It's with the parameter because I'm going to pass the name of the country that I want to count in the list above. So I'm going to make the country count into a global variable, country underscore count. Right now, as I was telling you, we will run a for loop for country in where I want to run it in log of country, right? That's where I want to count. That's where I stored all the countries, right? And then I want to say, well, which country, right? So I want to say if country is country underscore title. I'm going to provide the values later on to this one. Then do what? Then of course the counter now. Then country underscore count. You know, every time you encounter that particular country, then just do country underscore count plus 1. And then finally I want to return country underscore count. Okay, so this is normally what you would do. You would, in the end, you would want to return the country underscore count. It's outside the loop. So if we run this one, so this way we have run this bunch of code, but of course no output. We have just executed it. But if we want to make the function call, if we want to make the function call to this function, so I will say count underscore countries, and let's say I want to count how many times does my set have Afghanistan inside it, right? So let's see first. Afghanistan is 1, 2, 3 times. Okay, so let's run it. So here we go. So it gives me 3, which is correct, right? It's 3 times. But what if I run it again? It should still give me 3, right? There you go. It becomes 6. What happens if I run it again? It becomes 9. So basically the first time it's giving me the correct count. But if I run the same code again and again, then the results are no longer correct. And the reason is because the country underscore count is a global variable which is outside of the count function, the count underscore countries function. So because of the nature of the variable country underscore count, we have incorrect results. When we run the code the second time, the third time, or even if you run again, you will see it's giving us wrong results. Now, what if I were to do something like this? I will just copy this, yeah, and run it. Okay, and then I would just do the same thing again. Just copy this, paste it, run it again, take the same function that I wrote, except that I just explained to you the problem is because of the global nature of country underscore count. And then I will just delete it, and I will now run this one, run this cell, and after this I will just pass the same thing. I still want to count Afghanistan, but what I want to do here is in this function is that I want to pass this, rather than having it as a global variable which I already deleted, I want to pass that country underscore count as a parameter, which means if I want to make a function call, I got to pass this country underscore count to the function. So that's the change I made. I just deleted the global nature and I just passed the country underscore count as a parameter, included it as a parameter, and then passed it to the function. So I'm going to run this since I made changes to the code again, and then I'm going to run this one, and let's see what it gives me. It gives me 3. So the first time, we know the previous code also ran fine the first time, but it was the problem was when we ran it again and again, right? So let's try again. You see, it's running, and now every single time the code runs, it's giving me the correct answer, and this is by removing the global nature of the variable. We got rid of the global variable, and instead we used the country underscore count as an input to the function. So these are the kind of problems that can happen unknowingly when you are performing procedural programming, right? The program looks all fine, the function looks all fine, but these kind of errors unintentionally happen, and in order to avoid such things, we use functional programming, right? So let's talk about how would this work with parallel programming. If we had parallel programming, right? Spark splits up data onto multiple machines. So if your data was split onto, let's say, 2 machines, then the first machine will need to finish counting, and then it would return its own result to machine B, and then machine B could use the output from machine A and add to the count. In other way, I'm just trying to bring this procedural programming to a distributed system, right? Because now we saw the error can only be resolved when the country underscore count is not a global variable. If it is not a global variable, that means if you are trying to count on 2 machines, one machine has to finish the job first, and after that machine produces the output, it will pass on the result to the second machine, and then the second machine will add to it, because it is no more a global variable, because we saw the global variable in procedural programming gives us an error, right? So that then, by definition, although you might have 2 computers, but it's not parallel programming, because in parallel programming you would need both the machines to perform, to execute at the same time. But in this case, machine B has to wait until the machine A finishes, right? So these are different problems now that you can look for yourself, caused because of procedural programming. And even if we were able to solve new problems such as the implementation of parallel programming or distributed computing becomes quite difficult. We will see eventually how Spark solves these issues with a functional programming approach, right? Because in Spark, when our data is split, as you also saw in the MapReduce example, into multiple machines, each machine can simultaneously run a function to find out how many times does Afghanistan exist, because remember the tuples, right? So it just finds that individually on their machines, and in the end they bring the tuples together, and finally they get the results. So this is the difference between the functional programming approach and the procedural programming approach, and this was important to demonstrate to you that why does Spark choose the procedural programming approach, and why is it that procedural programming approach is efficient or is required when it comes to distributed computing, which is an essential requirement for big data. Now a bit more on this. Let's take this example. Let's say you are the owner of the famous steak shop down the road. A lot of steak shops exist in the market, right? They cook the same stuff, but different taste. Reason, each one has a different recipe, perhaps similar ingredients though, but the way they cook, Now, since you are the owner, your own recipe is the input to your steak cooking program, which produces the same steak every time you cook it, right? Because if you have a recipe, it should produce the same taste every time you cook it. Now, if you want achieve that, you need to make sure that the chefs in your shop exactly follow the rules in your recipe to produce quality steak every single time for each customer. Otherwise, your business will eventually be in ruins. I mean, why would somebody come if you can't produce a particular taste, a particular quality? I'm not an expert at steak making, but I'm assuming the following process. Let's say an important part of your recipe is to keep your mixed steak ingredients at a certain temperature before cooking them. However, when you start cooking, the room temperature keeps on increasing and might spoil the baseline steak mixture, because you would have more mixture ready, right? Once you're cooking one, you have mixture for others ready. So as you start cooking, the room temperature increases, and because an important part of your recipe is to have a certain temperature, then therefore that temperature might spoil the rest. In other words, your process or function must not have any side effects, because the increase in room temperature, because of the process, because you're trying to cook the steak and at the same time you're spoiling the ingredients unknowingly of the other mixture. So your process or function must not have any side effects at all. Spoiling the mixture in this case and affecting the variables in the case of the procedural example that we took before, right? So although it was trying to count, but at the same time it was affecting the variable, the global variable that we had. Every time we ran the function, it affected the global variable, providing us with a wrong result of the country count. Similarly, in distributed systems, you need to take care of the original input. Your functions should not change the original input. In procedural programming, these mistakes can occur easily, as you just saw one of them, and they happen very commonly, to tell you the truth. Therefore, Spark or functional programming, any functional programming approach for that matter, for distributed systems doesn't fiddle with the original input, but rather copies of it. As long as you keep these things in mind, your Spark code can easily manipulate big data sets at the level or the scale of big data. Well, now that we know that Spark leaves the original input data as it is because it does not want to create unintended side effects. This is good when you have a single function, but would we always have just one function, just like the code we just saw? Rather, we will always have multiple functions most of the time. I mean, the analytics is not just about running a single function. A program is not just about running a single function. It's usually a combination of many functions, and that is what happens most of the time. You can't process the data with a single function. If Spark makes an input data copy for each function, the functions will be independent and useless to the process of data processing or data wrangling. Because after all, the output of a program is achieved by data being processed using several functions when these functions pass data from one function to another function. Just like you might have written programs, you process input in one function, then return the value to some other function which processes it further and then gives it back to the other function, finally returning it to main, right? That is how programming works. So what about Spark? If each function has a different data and do not interact, then we will not be able to process and we will not be able to achieve the output. So Spark chains together multiple functions, connecting them in such a way that each sub-function performs a small part of the processing, and the result collation happens in the end. So in Spark, it still has the capability, the ability to connect, to chain multiple functions, such that each sub-function performs a small part of the processing, and in the end the result is collated and you have your happy ending. Another important thing, if Spark were to create a separate input data copy for each sub-function, we would eventually run out of memory. Imagine your Spark is duplicating your large data set for every single function. This would eventually run out of memory. Now Spark avoids this by a functional programming concept called lazy evaluation. Even before a Spark program touches your input data, it builds a map which is basically a sequence. It's a step-by-step directions of function execution and their specific data needs. What is the specific data need of a particular function and the other function and the other function? This map is built. So it only loads, it only provides what is required, not the entire thing. This directional map, this sequence is known as directed acyclic graph, or simply you can remember this as DAG or DAG. The DAG is basically Spark's way to wait until the last possible moment for data. It tells a function to wait until the last moment when the data is actually required. So rather than gathering data for functions every single time a function is executed, it waits till the end. Okay, so rather than gathering data for functions every single time a function is executed, it waits till the end and gets all the related data that the function requires all at once. So what is DAG? What are these sequences? What are these maps? Let's have a look at another example. Let's have a look at maps, lambda functions in context of the DAG, directed acyclic graph, or DAG, whatever you want to call it. So I will bring on another notebook, a separate one. I'm going to close the old one for now, create a separate notebook, because in this case I need to load Spark. I need to load Spark into the Google Colab, which is not there by default. Okay, previously I was just running some Python code, so I don't need to bring in Spark. I don't need to load in Spark. But now, before we try out the DAG maps and so on, I first need to load Spark into it, just like how you would install the Spark onto your local machine or the server. So there are a few commands that I'm going to run, and you would need to run them every single time when you want to load Spark into Google Colab. So this is how you do it. I use the apt-get install. I need to install the JDK first. Open JDK 8, JDK ls. Next time onwards, I'll just copy paste it from the Colab notebook, but maybe one or two times I'm going to write it so that you get used to it. Now I'm going to use wget to get it from us.apache.org spark dash 3.0.0 dash preview 2 slash spark dash 3.0.0 slash preview 2 dash bin dash Hadoop 3.2.gz. So this is available on the Apache website, and then I'm going to use the tar spark dash 3.0.0 dash preview 2, unpack it, Hadoop 3.2. So I'm going to use that package, and then I will also need to, I'll do this, and I will pip install Q from, this is from Spark, the find Spark. Okay, the find Spark, you would need this if you are trying to run Spark on a local machine. Connecting this, waiting for it to connect it. Okay, I'm going to run the cell. So we'll need to give it a while so that it can download all the necessary packages, the Java, the Spark, unpack it, and then install the Find Spark, which is necessary for if you're running a local version of Spark on a local machine. So it's trying to get it from there. Okay, it's starting to get it. You know, the circle is going round and round, so we'll wait for it. And there we go. So you can see it has been uploaded, downloaded from there, and let's see. And therefore, so you have it. I'm just going to, since I've been done, I don't need to see the output. I'm just going to clear the output, and this is, by the way, how you can clear the output by just clicking on it, and you can leave it as it is. You can even see there's a folder on the side. You can even see that the packages are here. Okay, later we're going to talk more about this side. Just a note at this point is that when you want to download the Spark packages onto your Google Colab, please make sure that you go to the Apache Spark website to check the latest version. Okay, just going to use a text cell. So you just go to https downloads.apache.org/Spark. So if you go to this, by the way, this is how you use the text cell. Okay, so you can see it's a text cell. So if you go to this URL, you can get all this information of the name of the package and so on, right? So always go and check latest Spark version. Okay, so we have done one part of getting our environment ready for Spark. The other part also, what you have to do is you have to import OS. You have to specify to your system where your environmental variables are. So I'm going to say, where is our Java? You know, so once you have done the previous step, your Java will be, it can be accessed from here. So this is JVM and Java-8 open JDK AMD64, and also for Spark. It's also giving you some suggestions, as you can see, but I prefer typing Spark_home. Where can I find it? You can find it in content, Spark -3.0.0. So basically we are pointing towards them so that our program can later on use them. .bin -Hadoop 3.2. Okay, I'm gonna run this one. Oh, I guess I made a small, it's here, just a spelling mistake, so it's Enron. So I'm going to try to run it again. Okay, so it works, no more errors. So I think I have set up the environment, right, for our Spark to be run. Now we can actually, our environment is ready to run Spark. So therefore now we can delve into more. So I'm going to write this, as I was telling you that you need to use Find Spark. If you need to import it. We have already used the pip install. You need to import it if you are using Spark on a local machine. So we will import Find Spark, and then we just find Spark.init. Okay, and then also you have to import PySpark. and this is, we are going to say PySpark dot spark context app name, can say, using that we can set the name of our app, the code that we're trying to run, you know, can call it maps and lazy evaluation DAG. So you can set the name of your Spark app. In here I'm also going to just load the variable, yeah, just like what I did previously. I'm going to put values in it. I closed that notebook, so I would otherwise just copy pasted this one, but let's just write it. I'm going to put Japan, and I'm going to put Afghanistan, and let's say I want to put in Havana. I'm going to put in Jordan. I'm going to put in Malaysia again, and I'm going to put in Afghanistan, but I'm going to use a small a this time. Later on we want to run some code and see the effect. Okay, so this done, and we also want to parallelize the log of countries. So what we want to do is, you can just say distributed country underscore log is dot parallelize log of countries. Okay, so I have imported FindSpark, PySpark, the countries are there, we have parallelized the data. Now what do we want to do with them? Let's just run it first to make sure there's no errors. So it's just trying to do the import and so on. So let's play with the code. Let me just try to write a function. I'm going to call it to lower case, and I'm going to, so basically I'm trying to convert a title or name of the country to a lowercase, return, I'm going to use the lower function. Okay, so return country dot lower, and I'm going to make the function call into the same code cell. You want to do another one, no problem, but there's no need to do that. So I'm going to call that function, and of course I need to pass in the value, the parameter. So I'm going to take in Malaysia and see, there you go. So now I pass in the value Malaysia, and then basically I have used the to lower to change the capital into small, the uppercase into lowercase, right? So let's write some more code. I have distributed, you can just click on this one, you know, it will just, and I will say dot map convert underscore country underscore to lowercase. So this code cell here, it will help us to apply this function using a map step. So what is the difference? That it will go through the list of the countries, and then it will apply the lowercase function to all of them, because in cell 8 we did that only to one particular value that we had. Now in this case, if we want to run it through Afghanistan, Malaysia, Japan, Afghanistan, Hawana, etc., so we will use the map function in this case, the map step, and then so that it is applied to the entire set. As you can see, it just gives me this Python RDE1 output rather than showing me anything. This is because of a lazy evaluation. As I told you, that Spark will wait until the end before it actually acts on the data. So in this case, although we did tell Spark to convert the country to lowercase, but we didn't tell him to display the results, show us the results, or perform any other action, right? So you actually need to have an action step for the Spark to actually execute the map step. So it will wait unless it's really required, right? So if you want this map step to be actually implemented, if you want the Spark to implement it, you need to use an action item. For example, you need to use the collect, can use show, So for example, if we just copy the same code and write it and just add to it collect. Okay, so this collect function, what it does is it takes the result from all of the clusters and collects them into a single list on the master node, right? It takes from all of them and then it will bring them to the master node. So basically, in other words, it is forcing Spark to actually act on the data. Since we're running on the local machine, let's just run it and see that if it makes a change. Is Spark now forced to display, to act on the data or not, right? There you have. Now you have forced Spark by using an action method. You have forced Spark to actually act on the data, because in number 9 Spark was not forced to, because you were just telling him about a map procedure, but it could wait until an action item was brought in. In this case, the action item is the collect function. So now that we run the code, you can see all our upper cases have been changed to the lower case, right? You should take a note as this, that Spark is not changing the original data set. As we discussed earlier, Spark just makes a copy. Now how do I know that? Well, run an action item on the original data set and see if the original data exists as it is or not, right? Your original data set is distributed country log. I just pressed a tab and I will just run directly on that one. Directly I will run collect, because of course you want to see the result, you have to have an action item. So I'll just store distributed underscore country underscore log dot collect, and let's see if the data set has changed, the original data set has changed or not. There you have, the original data set is as it is, with capital A, capital M, J, A, H, J, M, and then remember we had a small we wrote this Afghanistan, the second last one, with a small a, and Malta with a capital M. So you can see clearly that the original data set has not changed. You don't always have to write a custom function for the map step. You can use something known as lambda functions and the built-in Python functions like string.lower, right? So you don't have to write it every single time. Let's just write it down so that you can understand. So we have distributed log dot map, and here we have lambda country dot lower, and of course you want to perform the action, you got to use collect. Okay, this is actually a Python's feature for writing the functional style programs. Okay, so if you have this, we'll just run it. Okay, so basically we'll do the same thing, but you don't have to write a custom function every single time for the for the map step. So one more thing we want to do here, we want to distributed underscore log dot map. Again, you can say lambda x dot lower dot collect. If you compare the 14 and the 15, you will see that in that case you were actually saying country and country dot lower. So next time if you had a different a different data set, then you might have to change the function itself, but in this case you can just set it to x and so on, and then all you need to change is the data frame that where you have loaded your data set. That means if you have like distributed underscore country underscore log, if you have a different data set, you just change the name, and then the map step, which is the map step, you don't need to rewrite for that particular data set, because you're just denoting using the lambda function, then convert everything to the lower case. So this is you can keep stored functions to do that and apply them at different places. Okay, now if we want to data wrangle with Spark, right? If we want to data wrangle with Spark, it is essential, because so far we were just looking at the DAG, we were looking at the maps, we were looking at lambda functions and so on. But if you want a data wrangle with Spark, it is essential, of course, that we load the data into Spark, because so far you saw the data set that we had actually has nothing to do. I mean, we didn't load it, we just wrote it, right? They just stored a variable and so on, right? But if you want to data wrangle with Spark, it is necessary that you load the data into Spark first, right? And so far we haven't.